Remember, in algebra, we use variables to represent quantities we don't know. Now, although you're probably used to the variable x, in pre-calculus, we're going to deal with algebraic expressions where we use variables that represent the quantity we're finding. Like, if we're finding time, we usually use little t. If we're finding temperature, we use capital T. If we're finding distance, we use D for distance. Now, there are some certain types of algebraic expressions that we run across all the time. These are ones you should have already run across at some point in time. For example, the monomial. The monomial is a polynomial of degree 1. I shouldn't say it's a polynomial of degree 1 because it's not necessarily degree 1. However, it is a polynomial that only has one term. So an example of a monomial would be like 6. That's a monomial. Or 9x to the 5th. Or 10x squared y to the 4th z. These are all monomials. Now you may be looking at this one going, that's not a monomial. There are several terms. No, several variables and several terms are not the same thing. However, we do say that this particular monomial is degree 0. This monomial is degree 5. And the last one is degree 7. Now, the way we determine the degree is by the biggest exponent of the variables. Most of the problems we're going to deal with will look like these. We probably won't run across problems that have several variables within a term. So, for our purposes, the degree of the monomial is going to be the degree of x. So if there is no x, there's no degree. We say it's 0. Outside of a monomial, we had these things called binomials, and binomial meant two terms, binomial. So, for example, 6 plus x is a binomial, or 9x to the 5th plus y squared. And then we had something called a trinomial, and that meant a polynomial with 3 terms. So x squared plus 5x plus 6 is a trinomial because there are 1, 2, 3 terms. Anything after a trinomial was just called an nth degree polynomial. So after that, you don't have to remember any special names. When adding and subtracting polynomials, I just realized I spelled polynomials wrong here. Polynomials. Probably not correct. Let's see. Polynomials. There we go. All right. When adding and subtracting polynomials, you know that you're supposed to add and subtract like terms. However, with subtraction of polynomials, you have to be careful of one thing. So we'll start with the adding. This is how I like to do it. When I used to teach Algebra 1, I would make the students underline the like terms. So x cubed and x cubed are like terms. When I add them, you get 2x cubed. Remember, adding and subtracting polynomials, you add and subtract the coefficients of the like terms. It changes nothing about the variable, or the exponents of the variables. Alright, I have a negative 6x squared and a 5x squared. When I add them, negative 6 plus 5 is negative 1x squared. I have a 2x and a negative 7x. 2 plus negative 7 is negative 5x. And then I have this plus 4 that I have nothing to do with, so I'm just going to tack it on at the end. Here's the deal about subtraction. And this may be how you learned in algebra. You have to distribute the minus sign. There's really a negative 1 here that's going to get distributed. What I did in Algebra 1 was I would make them change this to a plus sign and change all the signs in the second parentheses, then add my like terms, because now it's an addition problem. X squared and negative x squared cancel because they're opposites. Negative 6x squared and negative 5x squared is negative 11x squared. 2x and 7x is now positive 9x, and I still have my plus 4 at the end. Multiplying binomials using FOIL. This may or may not be how you learn to multiply binomials. If you learned FOIL, you know that it stands for first, outside, inside, last. It's a nice little acronym. When you're multiplying binomials, it says multiply the first two terms together, and you get 6x squared. Then it says multiply the outside numbers together. The 2x and the negative 5 are the outside terms, so you get negative 10x. And then it says multiply the inside terms. 1 times 3x is 3x. And then multiply the last term in each binomial, and you get negative 5. And then you get these two numbers in the middle that are like terms, so negative 10x and 3x is negative 7x minus 5. Some of you may be able to skip this step. However, if you can't, don't. Now, we don't usually like to call this process FOIL because of the next problem. This is an example where FOIL doesn't work. We just usually call the process of multiplying polynomials distribution because the way that I learned how to do this back in the day was I would first distribute the 2x to everything in the second parentheses. So I would get 2x squared minus 2x cubed minus 10x squared plus 4x. And then I would distribute the 3. And I would get plus 3x squared minus 15x plus 12. And I think that's the most direct route for multiplying these together. And then you have like terms you can combine. These are like terms, and these are like terms. So my final answer is 2x cubed minus 7x squared minus 11x plus 12. However, there is another way you might have learned how to do this. If you learned this method, cool. If you didn't, it's kind of a neat little process. I call it the box method. I'm multiplying a binomial, so something with two terms, 2x and 3, by a trinomial, something with three terms. I have an x squared, a negative 5x, and a 4. And how you make this box really doesn't matter. I did 2 rows and 3 columns. I could have done 2 columns and 3 rows, and I'd end up with the exact same answer at the end. The way the box method works is you find the area of each of the squares. I realize they're not all squares, you have to pretend like they are. How do you find the area of a square? Well, you do length times width. You do length times width. Length times width. Length times width. Length times width. And length times width. And then the kind of the cool things that happens is these diagonals are your like terms. So I have 2x cubed minus 7x squared. Oh boy, I did something bad, didn't I? I did that bad. That should have been an 8x, shouldn't it have? So this should have been a minus 7. So if I looked at my answer key, I would have seen that should have been a 7. Minus 7x and plus 12. And I end up with the same answer. So it doesn't matter if you do distribution in this form, like I did, or if you use the box method. If you learned one of these methods over the other and you're comfortable with it, that's the method you're going to use. Some special products that we run across very frequently. Number 1 is called the product of a sum and difference. This is so important that you probably ran across it quite a bit in Algebra 2. I swear to you will run across it every couple of days in pre-calc honors. Number 2 is called the square of a sum. When you have a binomial that's being added and you square it, it's always a squared plus 2ab plus b squared. The third one is called the square of a difference. The fourth one is called the cube of a sum, and the fifth one's called the cube of a difference. And there's a reason I put a star here. There is a particular section that we will cover later in the year, not too distant future, called sequences and series, and we're going to talk about something called binomial expansion. And the sum and difference of cubes will come back in that section. There's actually a pattern for how you'll know that these are the answers. Using the special product formulas to expand things takes an understanding of the process called substitution. So, in order to find 3x plus 5 squared, if you look back at the previous page, when you square a sum, you get a squared plus 2ab plus b squared. And you need to know what a and b are. Well, a is 3x, and b is 5. So I'm going to have 3x squared plus 2 times 3x times 5 plus 5 squared, which is going to be 9x squared plus 30x plus 25. Now, do you have to do it that way? No. The other way you could have done it was, if you remember that squaring something means multiplying it by itself, you could have done this and then used FOIL. But one of the most common mistakes that students make is they think that they can distribute the exponent. You cannot distribute an exponent over addition. Cannot. I think I said that enough. Alright, now let's go look at x squared minus 2 cubed. In order to do that, the definition for cubing a difference was a cubed minus 3a squared b plus 3ab squared plus b cubed. A is x squared. B is 2, not negative 2. B is 2, because remember the definition is a minus b cubed. Alright, so now I'm going to go plug it in. So I'm going to get x squared to the third minus 3 times x squared times 2 plus 3 times x squared times 2 squared plus 2 to the third. X squared to the third is x to the sixth, because that's the circumstance where you multiply the exponents, minus 6x to the fourth, plus, since this is 4 times 3 is 12x squared, plus 8. And again, we'll talk about these again when we talk about something called binomial expansion, and you'll actually memorize this. Not because I'm telling you to memorize it, but because it's got a unique pattern. Let's use some more special products. In A, I want you to notice that this is the a minus b, a plus b format. Doesn't matter what order it's in. When you multiply it out, you get a squared minus b squared. So you get 2x squared minus the square root of y squared. 2x, when you square it, is 4x squared. And when you square a square root, those are opposite operations. They cancel each other, so you really just get minus y. For B, it really is a special product. However, if you don't recognize it as a special product, you can always go use the box method. That's the one I would have done x, y, negative 1, x, y, 1, and then multiply it out that way. The diagonals would be where your like terms are. But I'm going to show you where why it's a special product. It is actually a plus b, a minus b, where this is a and this is b. So if it's a plus b, a minus b, when I multiply it, I get a squared minus b squared. So I get a squared minus b squared. X plus y, when you square it, is also a special product. It's a plus b squared, which is a squared plus 2ab plus b squared. So it's x squared plus 2xy plus y squared, and there's a minus 1 at the end. So this problem really had two special products in it. Now, again, if you had used the box method, you would have ended up with this exact same answer. Factoring is the inverse process of distributing. This way is distributing. This way is factoring. So if you have something in the form a squared minus b squared, it would factor into a plus b, a minus b. So this direction, it's actually called expanding. Expanding means multiplying out. And this direction up here is the factoring, where you're creating these things called factors. So x minus 2 is a factor. X plus 2 is a factor. Factoring is one of the more difficult processes we go through because there isn't just this one special way of factoring and it works every time. There are different things we have to look for. So one of the first things we probably learned how to factor was something called the greatest common factor. When I am looking to factor polynomials, I always look for a greatest common factor first. So in A, 3x squared and 6x, the greatest common factor is 3x. Both terms are divisible by 3 evenly, and they're both divisible by x. So when you divide them both by 3x, the first term you're left with an x, and the second term you're left with 2. So 3x parentheses x minus 2 is the factored form of 3x squared minus 6x. In B, there are 3 terms. So the greatest common factor, 8, 6, and 2 are all divisible by 2. X to the 4th, x cubed x are all divisible by 1x. And y squared, y to the 3rd, y to the 4th are all divisible by y squared. Usually what I do with the variables is I look for the smallest exponent that tells me how many I can take out. So when I divide each of the terms by 2xy squared, the first term is left with 4x cubed. The y squareds cancel because what's y squared divided by y squared? 1. The second term you're left with 3x squared y. And the third term you're left with 1y squared. Because 2 divided by 2 is 1, x divided by x is 1, and y to the 4th over y squared is y squared. So this would be the factored form. The third one is probably not like one you've seen before, which is good. I want in the honors class for you to be exposed to problems that we don't give the regular kids. I claim to you that these have a greatest common factor, and that greatest common factor is x minus 3. So if I take x minus 3 away from both of them, I'm left with 2x plus 4 from the first part and minus 5 from the second part. So I've got x minus 3 parentheses x squared, 2x minus 1, and that would be the factored form. I hate that this next one is called factoring x squared plus bx plus c by trial and error, because it really isn't trial and error. When we have trinomials, this is for trinomials, whose leading coefficient is 1. The way that this works is we look for two numbers that when you multiply them, you get the last term. But those same two numbers, when you add them, give you the middle coefficient. The reason that happens is if you think about this example, x plus 2, x plus 3. When I multiply this out using FOIL, I'm going to get x squared plus 3x plus 2x plus 6. The middle terms are my like terms, so I get x squared plus 5x plus 6. So I want you to notice the last term is the product of 2 and 3. The middle term is the sum of 2 and 3. And it's very unique that that happens. So if you think about all the pairs of numbers that multiply to give you 12, only one of those pairs adds to give you 7. So the answer must be x plus 3x plus 4. This is the last problem I'm going to do in this video, and then I'm going to talk about graphing on the calculator as a technique for helping factor. I want to factor something of the form ax squared plus bx plus c. That means there's a leading coefficient of something other than 1. The way this problem works is you multiply the first and last term. So instead of looking for two numbers that multiply to give me negative 5 and add to give me 7, I'm looking for two numbers that multiply to give me negative 30 but add to give me 7. And the problem with negative is that you run into this. I don't know which number is negative. But you usually don't have to sit and think for too terribly long before you run across the answer. Look, there it is. So I'm going to rewrite this as 6x squared minus 3x plus 10x minus 5. What I did was I took the middle term of 7x and I rewrote it as negative 3x plus 10x. The reason I did that is because they're like terms. And then we do something called factor by grouping. I group the first two terms together and I group the next two terms together, and then I'm going to factor each of those parentheses independently, finding the greatest common factor. 6x squared minus 3x has a greatest common factor of 3x. When I divide each term by 3x, I'm left with 2x minus 1. Remember, 3x divided by 3x is not 0. The second parenthesis, 10x minus 5, has a greatest common factor of 5. When I divide by 5, I'm left with 2x minus 1. Now if you think back to that problem earlier, where was it at? Here. Remember how both of these had a greatest common factor of x minus 3? Well, that's in essence what I'm doing here. Both of these have a 2x minus 1. And when I take it away, I'm left with 3x plus 5. And that's the factored form. In the next video, I'll talk about using the graphing calculator to factor.